Welcome to NASA Edge, an inside and outside look at all things NASA. Today we're joined by Carrie Scott, also known as CJ, who is part of NASA Langley's Sci-Fly team. Carrie, how you doing today?
I'm doing great, Franklin. How are you?
Pretty good. Now first, tell us a little bit about what Sci-Fly is and what you do with that team.
Yes, so Sci-Fly stands for the Scientifically Calibrated In-Flight Imagery Team. So what we do is we take imagery, engineering quality data sets of various flight tests, whether that's spacecraft that are re-entering the atmosphere or rockets that are exiting, the atmosphere, parachute systems, sample return capsules, you name it, and we will do our best to image it.
Now, as the Deputy Principal Investigator for Sci-Fly, what is your exact role on that team?
That's a great question, and a little bit harder to pin down. But what I am responsible for is making sure that all of the scientific systems that we use, optics, windows, aircraft, are operational and ready to go in order to collect the data that meets the requirements as set by our customers.
Now, when we first met, it was down in Houston, and one of your flight systems, the WB-57, was being used to do some parachute tests. What other type of flight assets do you have as part of the Sci-Fly team?
Well, so we use a variety of different assets that fit the need for the mission. So sometimes re-entry missions occur over water, so the asset would need to have a long endurance. For a mission like that, we may operate in conjunction with the Navy P-3 aircraft, which has a cast glance imaging system. For other situations over land or that don't require as high an altitude ceiling as the WB-57, we may use the NASA G3 aircraft, of which there are a number. And also, as you mentioned, the WB-57, which is a great high altitude imaging aircraft. So it really depends on the mission profile and the imaging that needs to take place.
Tell us about your recent mission, Hayabusa 2, or Shark, that was managed out of Australia.
Oh, wow. That was such a fun mission and just such a great data set. We were asked to help coordinate an imaging mission for the Hayabusa 2 sample return capsule reentry. Hayabusa is a Japanese exploration agency, JAXA, sponsored mission to capture asteroid material from the asteroid Ryugu. And the sample return capsule was set to re-enter the atmosphere on December 6th. The capsule is about 40 centimeters in diameter, so, about the size of a beach ball. And we were going to be imaging it from approximately 400 kilometers away. This was going to be a spectral measurement, and so we worked to develop imaging spectrographs that provide us lots of information about what's happening to the heat shield as the capsule, slams into the atmosphere. It reaches, Mach 42.5.
How do you acquire your targets when they enter the Earth's atmosphere?
Well, that's a great question. We're provided a trajectory from the customer, and we have tools that we use to graphically illustrate the trajectory in a simulated 3D, virtual environment that is a very high fidelity model of the solar system. What we can also do is generate a map of the stars that we would predict to be within the field of view of the imagers. So we create a star map of the background stars, and by overlaying the trajectory on the star map, we can prepare appropriately to point our systems where they need to be and kind of wait for the target to appear within our camera.
Well, that is great to hear. After this quarantine is over, I look forward to catching up with you and the rest of the Sci-Fly team back at Langley. Thanks for joining us today, CJ.
Thanks.
You're watching NASA Edge, an inside and outside look at all things NASA.